Hello everyone, thank you so much for being here. My name is Saad Tariq and I currently work at the Office of Career Services. Today we have with us Karine-Frédérique Loriot, who's the Associate Dean of Career Services. Karine, I'll give you a few minutes to introduce yourself, say some nice things about NYU and the program, and then we'll move forward.
Thank you so much, Saad, for the introduction. And Debaleena, thank you for including me in your event today. Nice to meet those of you that I don't know here yet. And so as Saad mentioned, I'm the Associate Dean of Career Services at Tandon, and we started partnering last summer, started having conversations with STEMaway in last spring after COVID became a reality for us. And STEMaway has just come together to propose an amazing array of projects, of opportunities to students, really adapting something that wasn't really meant to be virtual, fast forwarding and offering it to so many students at Tandon and other schools, other colleges and universities. The feedback we had from Tandon students who did the program was simply fantastic. It was informal emails we received thanking us for putting them in touch with you, Debaleena, and your team. Overwhelmingly positive. So we were so happy that this opportunity came our way. We're even happier that it continues to be a reality and something that is that you're taking, even making bigger. So I'm extremely happy to be here with you and seeing students showcase their work from this past project.
Perfect. Thank you so much for your kind words, Karen. Now I'm gonna move the conversation to Debaleena, who's the founder of the STEMaway program and the person who initiated all these opportunities for everyone during the pandemic. So Debaleena, do you have a few words to say for everyone?
Absolutely. But first of all, thank you, Karine, and thank you, Saad. It was my pleasure to get to know quite a few remarkable students from NYU this summer. In fact, working with students is the highlight for me for STEMaway. So my life as founder of STEMaway is very different from my previous life. My background is in tech. I was a hardware engineer at Intel. My passion is for zeros and ones, data patterns, and I hold several patents related to microprocessors. But coming back to STEMaway, the STEMaway Virtual Internship Program is a very unique program in terms of both project content as well as project structure. So in the project content, the material is very, very challenging, but the unique part is that we let students do the entire project from project definition all the way to the project analysis. So this is different from if you were holding an internship or even an entry-level job where you tend to be a cog in the wheel for a while. And the best way to understand what I'm just saying is to hear from the students who were there in the past session. So today we are going to hear from the students will present the machine learning pathway as well as UX UI. And the UX UI is part entrepreneurship, part UX UI. This summer, we also had bioinformatics and full stack. And currently we are adding AWS DevOps and hardware engineering FPGA. So many challenging pathways coming up, very, very interesting pathways coming up, new ones as well. The best way to learn about these programs is we have currently pathway hubs ongoing on the platform. So these are mentor-led programs where we're just giving students a chance to get trained for the upcoming virtual internship sessions. And if you go onto the platform and join these pathway hubs, you'll get to learn much more about each of these pathways. So coming back to the project structure, it's just like a mentor chain. It's literally a mentor chain. So we have industry mentors mentoring the leads. We had some excellent leads from NYU, and they in turn were leading student teams. And by doing this, we are able to provide the opportunities at scale. And by being in a lead position, you're building, students are getting this chance to build leadership skills, mentoring skills. And this is what will really help you in your careers, not just getting that first job. We are a full-scale career hub. So there's a hiring portal that is attached to the virtual internship program, which is going live early next summer. But STEMaway is really not just about your job, but about your career. And what we want from our students is we want to give our students the chance to really get satisfaction from the career they choose. Over to you, Sam.
Perfect. Thank you so much for explaining the program, Debaleena. And I will see along the course of the presentations how everything she said is reflected in our work as well, how we took the lead, how we took the initiative to finish our projects. And now we're gonna move towards our guest, Mr. Pratik Sarkar, who's an ML engineer at Google currently. He works on how people comprehend visual content and works in helping the world's visual information be transcribed into a way where people can use it all across the world and be universally accessible. He currently lives in Bay Area, and according to him, he lives with his wife and moderately cute children. I did not use those words. So we're gonna, Pratik, do you have a few things to say for us?
Thank you so much for having me here. The very first time that Debaleena talked to me about this idea that uh, I really want to do something to enable people to learn what STEM is really about, and to essentially have this mentoring be part of their training automatically. Her vision and I should say her sort of quiet conviction is really inspiring. So I'm really happy to be here. I look forward to hearing about everything that you have to say. Uh, Let me sort of share a few things that I wrote down today. I hope that this is going to be something that all of you share, because you are all in STEM. So I wanted to talk about why I am in STEM. So the short answer is because that is a bucket people put me in. That is why I am in STEM. And let me elaborate a little more why I say that. What did I get? What did I do to get to STEM? It was very simple, actually. I just found fun in elegantly posed puzzles and problems. That is how I got to STEM. And I'll go through some examples. Maybe you'll remember some of these from your own school and college days. You must have heard the story of this teacher who wanted to take a break or take a nap and asked the students to add up all the numbers from 1 to 1,000 or 1 to 100. Different stories go different way. All the students started getting busy at work. One guy stared at the problem for a little while, saw that he could just reverse the sequence and then form these groups that gave him 1,001s. And there, voila, he had the answer. This is so beautiful, so elegant. This is the kind of thing that got me into what we think of as STEM. Here's another example. This is in physics, where we are trying to model phenomena in the real world. And this actually is to some extent attributed to the same guy who found that solution, Carl Friedrich Gauss. So there's this Gauss law for gravity and gravitational fields. But let me tell you the problem. So suppose you are in a planet, not on a planet, inside a planet, a hollow planet. So this is a perfectly spherical planet. Look at how the posing of the problem is making simplifying assumptions to make the problem approachable. You are in a hollow, perfectly spherical planet with uniformly distributed crust. So uniform density of the crust. Inside this planet, how would you go about figuring out how much you would be pulled by gravity and in what direction? It turns out that inside this hollow planet, you would have zero gravity. And it took me a few days. When I first tried, I really made sure that I didn't look at any books. I didn't talk to anybody. I wanted to do it for myself. And when I finally proved that it was going to be zero gravity, that was a discovery that I sort of patted myself on the back, and I really enjoyed. And I sort of decided that I was going to learn more about these. And then, of course, I found that Gauss had stated it so beautifully in terms of this law of gravitational flux. I'm not going to go into details of that. If you don't remember, you could look it up for homework. Here is another example. This one I heard from the late Professor Thomas Cover here at Stanford. Very simply stated problem. A 6 foot tall high jumper can clear 6 feet on Earth, goes to the moon, where gravity is 1/6 of what it is on Earth. How high can he jump on the moon? And you might think that, oh, it must be 6 feet by 6 feet, since mgh is the potential and that's linear in height. But no, that's not the case. You are neglecting over there. You might have been thinking of everything as little fleas or point masses, but people actually have a weight distribution over their body, over the 6 feet. So the center of gravity is somewhere at around 3 feet. When he clears 6 feet, he has lifted his center of gravity by about 3 feet. So the gain that he's going to have is 3 times 6, not 6 times 6. But the beauty over here is that once we went from a gravitational field, which follows the inverse square law, to simplifying it and approximate it for near planar surfaces, where the potential is linear in height. From there, you can easily form this concept of center of gravity, one single point at which your entire mass can be concentrated. And if you make that assumption, you're going to be able to solve so many difficult problems with such ease. That is what STEM is about. I wanted to sort of show a few other fun examples. So I got my son to be a model for this. You can find the center of gravity of any stick by putting your fingers resting the stick on your fingers and slowly moving the fingers closer to each other. Where they meet, that's the center of gravity of the stick. It turns out that this works for any kind of stick. It doesn't have to be uniformly distributed mass over the stick. In this case, it's a bow for a violin, which has ununiformly distributed mass. It's heavier on one end. I can still find the center of mass that way. And this has to do with the way we learn, we found out about how the laws of friction work. Here's another one. You might know that if you line up a set of nearly identical balls and you strike that line with one ball from one side, exactly one ball goes out the other end. If you strike with 2 balls, exactly 2 balls go out the other end. If you strike with 4 balls, exactly 4 balls go out the other end. And it turns out that it's really beautiful. The constraints are conservation of momentum and conservation of kinetic energy. And once you have these two, you end up with a set of quadratic equations. It can have 2 solutions. One solution was the input state. And by symmetry, the output state has to be near identical. So a new problem. Suppose you have a foot rule, which is unmarked. Right? It's just the length of 1 foot. And I give you this foot rule. Can you accurately measure the height of a person with this? How accurately can you measure the height of a person with this? It turns out that you can measure the height to arbitrary precision. What do you need to do? Start off with a random point on the body and mark out points 1 foot apart as long as the points are still in the body. Now count how many points fit. If you're just above 4 feet, then in some cases you're going to get 4 points. In some cases you're going to get 5 points. You average this out, that is going to be a pretty accurate estimate of the height of a person. So this, I came across the formulation of this problem because I was studying how scanners work. And I extended this to 2 dimensions and came to this concept of a modulo grid diagram, which I won't get to today, but you can follow it up. There are lots of unsolved problems still over there, but it's beautiful. Even these patterns are beautiful to look at. Many of you are applying machine learning for real world problems. OCR has been one of the classical machine learning problems. Now you're applying it to much more complicated stuff like natural language understanding. But I did quite a bit of work on OCR towards the tail end of OCR research. If you find a character like this could be either a 1 or a 7, right? However, if you see that next to that character next to this is clearly a 7. The other one must be a 1. However, if you see that character next to it, that was really a 1. This new character is what a 7 looks like. And different people have different writing styles. And these styles induce statistical dependence amongst the different patterns that you produce. And I studied this, and this was called it style consistency in isogenous patterns. I have to tell you a little bit about what I do now. I've been telling you about all kinds of fun that I've had throughout my life. I work in Google image search. So in image search, if you search for, say, a flower vase, we give you lots of beautiful pictures of flower vases. You can scroll through these, look at these beautiful pictures. Our goal, our mission is to make the world's information, visual information, universally accessible to all, and make it visually navigable. What does that mean? Out of all of these results, if you clicked on one particular result, that is the first visual cue that we have about what you might be interested in. And we have this feature called related images. If you're not familiar with this, you can give it a try. And if you find bugs, please do file bugs. There's a button right on top, and we actually have people who scoured through bugs filed by users. But our objective is to give you a chance to navigate through this world visually. You didn't have to know what kind of terms to use to describe this middle image. But when you liked it, we can show you other images like that. Perhaps you'll even learn what kind of a flower vase that is by just exploring. So that's the thing. So what did I do to get here? And here I'm going to start digging into my Indian roots and start using flowery language, because why not? Yeah, you know. So the language is this: centuries of masters created disciplines of thought and turned them into playgrounds, beautifully manicured playgrounds with beautiful rules and beautiful pathways, very elegant designs, and adorned them with fun problems and puzzles. That's what attracted me in. So I went in to those playgrounds to have fun. And in the process, I learned a few life lessons: curiosity, rigor and perseverance, self-critique, a love of elegance, simplicity, clarity, and structure. These are all that came out from that training that was laid out for me by the greats who discovered these spaces, but also my teachers. So the last important point is the ability to take a complex problem and simplify it, and to find a structure of a solution. And that is where the role of a mentor comes in. As I progressed through my career, I faced more and more difficult, open-ended problems, not well-defined, neat problems that I could apply laws to. But it was now my job to try and find discipline in there, simplifying assumptions in there to make the problems tractable. So why am I'm in STEM? Because that's the bucket my work fits in. I would have taken these life learnings. I actually do take these life learnings everywhere. Even when I practice music, I apply these same things. That is just part of who I am. But my STEM employer finds value in my bringing these traits to problem solving. That's why I'm in STEM. So that's what I wanted to say to you. And I'm really look forward to hearing about all of the lovely work that you have been doing. I got a little bit of a glimpse, a couple of minutes worth of glimpse from Debaleena, but I really look forward to hearing about what you have been working on.
Thank you so much for that, Prateek. That was amazing to hear your journey and why you've been in STEM. And I feel like most people who are on this meeting would have similar things to say, why they found themselves in STEM fields or in STEM positions or in internships like that. And I think it's communal, the love for problem solving within the STEM field and the STEM disciplines. So Debaleena, I think moving forward, we're going to start ahead with the presentations, and we're going to begin with the machine learning project, which I was the project lead for. And we built a tag annotation tool with machine learning. And moving into our agenda for the day, we'll have proper introductions of our team. I have two of my teammates here. We are going to move into the project definition, the problem statement, and how we thought we were going to deal with that, the architecture that we used, the project execution in terms of the steps, exact steps chronologically we took to execute this project, our comments on what could be possible future work for the product that we made, and then we'll open the floor for some questions and answers at the end of it. Okay. So my name is Saad Tariq. I introduced myself briefly at the start. I was the project and the product lead for this machine learning product. I'm currently a master's in industrial engineering student at New York University. And I would like to introduce my technical lead as well, because he was a huge contributor as a part of this project. His name is Somya Goswami, and he's currently a PhD student in electrical and computer engineering, while also getting a master's in data science at the University of Rochester. Sai, would you like to introduce yourself?
Sure. Hello everyone, I'm SaiLikhith. I'm studying second year Masters in Computer Science from NYU.
Perfect. And Hui?
Hi, I'm Hui Wen. I am a junior studying math with minors in computer science and data science here at NYU as well.
Perfect. And we also had our teammates Shalini, Saad, and Karandeep, who are also huge contributors to this project at different stages, who could not be with us here today. So moving into the project definition, we the problem that was given to us at the start of the project was, it was open-ended, and what we knew was that we want to improve the tagging that exists on the STEMaway forum. And over here, what we can see on the slide is an example of, on the top is an example of bad, what we would consider not good tagging or bad tagging, where it's not defined and there's only one tag. And on the bottom half of the screen is what we consider as good tagging, or what was the desired level of tagging we wanted on the forum. And why there were tags missing was, there's a couple of problems that fed into why we were not getting the tagging behavior we want on the forum. So if you can see here on the right, this is the mechanism, or this is the interface when you make a new topic or new comment at the forum. This is the interface that you have to deal with. And we identified three major problems with the current system that was in place for the tagging. The first one was that there is no algorithm, or the algorithm is very inefficient to predict tags. So there is actually no model that takes into account what the user is writing. So the user just has to go and pick relevant tags from a list of all available tags. Hence, being said, the interface does not encourage tagging. There are no recommended tags for the users over here. And the last problem that we identified was that the new user fed tags, or the new user comments, they are not used to improve any model or any system, which we think is key, because STEMaway is gonna, it's already exploding with new comments and self-assessments and topic titles coming in every day. And we feel like we should use that new information to keep improving our models. So given this problem statement, we came up with our product requirements at the start of the project. And what the product requirements that we set for ourselves were, we're gonna have actually build a model, a machine learning or deep learning model that's going to recommend relevant tags, not a whole list of tags. And as a benchmark, we're gonna say that it's gonna have an accuracy greater than 70%. The next thing we set for ourselves is we're going to have an annotator tool. So something that actually prompts the user to put the tags in instead of them looking for them in a list. And the third thing was, these new comments plus tags that we're encouraging the user to select, we want to use them for our future work. So we're going to integrate active learning as a part of this project as well, and as a part of this product. So now I'm gonna show you the product architecture diagram, and I think it's necessary to show this in the start, and we're gonna discuss each of these individual steps as part of the presentation ahead as well. So the user journey starts at a user comment, which is a part of our annotator tool. A user puts a comment in an annotator tool, which is fed as test data to our model, and we'll discuss what these models look like and how they work. So the model then predicts a number of tags for a user fed comment and shows it to the user as a part of the annotator again. So now the user who's written a comment and he's getting 10, 12 recommended tags, he can choose from them. He's like, I only think these four are relevant for the post that I'm making. So he writes his comment, chooses those tags, and within our system, there is the new user comment plus the tag annotated. It gets stored into a buffer database that we made. And this buffer database is actually very key to the active learning that we set up. And we're going to talk about this in further slides as well. But this was the basic architecture that we made and the basic diagram that we worked to expand our product off. Moving forward, we're going to move into project execution, and my wonderful teammate Huen's going to take it away from here.
Thanks, Saad. Okay, so the first thing we needed for the project was to actually get some data which we can train our models on. So as a group, we chose to scrape our data from the Stack Exchange forum. This decision was made from a few considerations of factors. So first of all, Stack Exchange is a very widely used forum. It has a large user database with various posts in a large number of categories which are very relevant to the STEM Away forum. Second of all, we observed that this Stack Exchange forum is very well annotated. They have tags that are relevant for each post. And adding on to that, there is a voting system on the platform, which further gives these posts and its tags extra credibility and tells us that it is indeed relevant. And lastly, seeing as Stack Exchange has a decent or a good tagging system, we thought that we would want the STEMaway forum's tag recommender system to model the same type of behavior as what we see on Stack Exchange. And so considering all these options, we made our choice to move on with this. So in this next slide, you can see a sample of like a data point that was collected, shown in this table above. For each post in the Stack Exchange forum, we collected the topic title, the content, and all the tags that are associated with the post. As a group, we managed to scrape a total of 60,000 data points from the forum. And from those 60,000 data points, we obtained 480 unique tags that were related to machine learning. However, we did consider that, and we thought that predicting 480 tags from 60,000 data points would be challenging, and some of the obtained tags were less relevant than the other tags to our specific use case, which was the STEMaway forum. So because of that, we chose to reduce the number of tags we would like to predict from 480 down to 25. And these 25 tags were chosen based on the frequency that they appeared on the forum, and also the relevance of each of these tags to the post that we would normally see on the STEMaway forum. And so reducing this number of predicted tags made our project a lot more manageable. And so with this, we could move on to the next step, which is building a model. And I will pass it back to Saad.
Perfect. Thank you so much for that, Huen. So now we're going to move into the modeling approaches and how we evaluated these models. So when I was given the problem statement, we really went back, did some research, me and the technical lead, along with our team as well, on what the tagging problem is outside of the scope of our project as well. And we found out it's still very open-ended, with people coming up with new and creative solutions every day, you know. So me and my tech lead, we thought it best to make our own solution for our problem instead of taking somebody else's solution. So we sat down and we thought about it. And once we had reduced the tags from 480 to 25, we thought it was best to make it a multi-label classification problem, because doing a multi-label classification with 25 classes is a lot easier to do with higher accuracy than it is to do with 480 tags. And what we had to do to build a model like this was, there's basic two-step approaches that we had, two steps that we needed to do. We had to transform our comments and topic titles into vectors, or into numbers that the computer can understand. And this is what people call natural language processing. And we did it using two different ways. We used the BERT model that's made by Google, and it would give us a vector of 768 attributes. Or we could use TF-IDF vectorizing, which gave us actually a good control over the number of features we wanted for our comments. And what we did for the tags were we made a tag vocabulary list. And this tag vocabulary list was one hot encoded for every comment. So this comment with 768 features or 4,000 to 6,000 features for the TF-IDF would individually get mapped to its own to its tags for its vocabulary list. So in this example, for let's say number one, we can see that machine learning and reinforcement learning is a tag. And down below in the dictionary, we can see there's 5 tags in total. So for topic content one, only the machine learning tag and the reinforcement learning tag is one hot encoded, whereas the other ones are left as zeros. So this is how we made our multi-level modeling or mapping approach for this problem. So moving on, what kind of different models that we use? There's different models we can use to classify, and there's different ways we can create vectorization for our topic contents as well, right? And we came up with 3 basic models that all of us tried. The first one was BERT for vectorization of the topic content, followed by feed-forward neural network for classification. TF-IDF, the second one was TF-IDF was for vectorization, and the feed-forward neural network for classification. And the last one that we tried was TF-IDF for vectorization and logistic regression for classification. And there are pros and cons to all of these, some being that BERT gives you a limited number of features, whereas TF-IDF gives you a range of features where you can choose whether you want 3,000 attributes or 6,000 attributes, and that does have an effect on accuracy for our model. Whereas on the classification side, a feed-forward neural network would take a longer time to train and a longer time to predict, whereas logistic regression would take a smaller time, but the accuracy might not be as well. So there are some trade-offs for each one of these models. And we're going to look at how we chose these models based on the metrics that we wanted to evaluate. And the metrics that we looked at for each model was the precision of a model, the recall score of a model, and the F1 score of a model. And what precision does is the precision penalizes the tags that should not have been labeled, but they were labeled as part of a prediction, whereas recall penalizes tag that should have been labeled but were not predicted. And it was confusing for all of us in the start for when we started doing multi-label classification, like what does this mean in our case, so if we look at the bottom half of the screen, there's a beautiful example that just illustrates what a true positive, true negative, false positive, and false negative would be in our multi-label classification approach. So given we had this very simple topic title, which is better, machine learning or deep learning for classification, and all the tags that were available to predict from, we can also see the actual tags that were predicted by our model, which was machine learning, deep learning, classification. So the actual tags are the ones that were actually associated, the machine learning, deep learning, and classification. Whereas the model predicted the tags, machine learning, classification, clustering, and statistic from the vocabulary list. So on the matrix here on the right, we can see which ones should have been predicted, which are being the false positives, clustering and statistics. Then we have the not predicted, but should have been predicted, the deep learning. And this is how we build our metrics for model evaluation. Moving forward, now we can actually see what the evaluation looked at different probability thresholds. Oh, so we see that BERT gave us a good precision at higher thresholds, but like the recall score and the F1 score really just fell down. And the TF-IDF model was overperforming the BERT model. It was doing a better job, even though that we assumed that BERT was going to give us better embeddings because it was contextual embeddings. But the TF-IDF model was, because we could control the feature size on it, we got a better model. We selected the number of features, optimized number of features to give us the best performing model. And that gave us a higher accuracy than the BERT model. And if you can see at the bottom half of the screen, the TF-IDF model plus the logistic regression one was the one that was doing the best job. But we really couldn't use it, because it had limitations in what it meant for the project. And what it would do is we would have no control on the number of tags that were being predicted by this model. Sometimes it would predict 2 tags, sometimes it could predict 8 tags, and we were not okay with that for the scope of our project. So Moving forward for our project, the model that we finally chose to work with was TF-IDF for vectorization and neural networks for the classification. So now we're going to move into project execution, and I'll pass it back to Hui Wen to talk about the different prediction methods that we used.
Thanks, Saad. Okay, so now that we have decided on which prediction model we were going to use, the next step was to decide on how our model would actually predict the relevant tags. So how our deep learning model worked was that when a user inputs a post, the model will give us a probability of whether or not each of the 25 tags would be suitable for that given post, with 1 being the most suitable and 0 being basically not suitable at all. And after obtaining these probabilities, we had 2 ideas as to how the tags could be predicted and outputted to the user. And these methods will be explained in more detail in the following slides. So our first method we tried was by using probability thresholds. How this works is that we would set a threshold at which we determine would be like a good indication that a tag is relevant to a post. For example, if we set the prediction threshold at say 0.5, all the tags that were given a probability of 0.5 and above from the deep learning model would be predicted as possible tags or relevant tags for the post, and while everything below 0.5 would not. So intuitively, as the prediction threshold increases, the number of tags that were predicted by the model decreases, as can be seen in this chart shown in the slides. And we found that this was actually giving us an issue, because if we set the threshold too high, the prediction model only gave us a very low number of tags. For example, if you look at the chart, from about 0.7 and above, the average number of tags predicted for each post is only about 1. And what's even worse was that the one tag that was predicted is usually really broad, such as machine learning or Python, which did not actually give us sufficient information about the post itself. On the other hand, though, if we lower the prediction threshold, we would encounter cases where there would be an overwhelmingly large amount of tags predicted, and that number was very hard to control. And we also found it really hard to check how relevant each of those tags are, because they might give us 15 tags and there was just no clue as to how relevant it actually was, and we did not want the user to browse through 15 tags to be able to tag their post. So that leads us to our next prediction method, which is the n most likely tags method. So I think this method is pretty self-explanatory from the name. Basically, it would output the top n tags with the highest probability values as the predicted tags to the user. And we implemented it that the tags would be shown in descending like probability order, so that the most likely tags would appear first to the users. In this slide again, you can see one of our instances, and so in our instance we chose the number to be 10. And so this is a sample of the 10 tags that were predicted for a particular post, again listed from the most probable to less probable as the list goes down. And we like this prediction method because I think it gave us a sense of control and consistency as to how many predictions a user will actually see every time they make a new post. And to add to that, by sorting these predictions in descending probability order, we will make sure that the users would see the most relevant tags first without having to browse through a really long list to actually get a sense of what tags are relevant. And so with this, the prediction model has been decided and we were ready to move on with the implementation. And so as mentioned, after that, the deep learning prediction model and the prediction method was pretty much done. And so the bulk of kind of like the backend work for the recommender model was completed. And this is just an example of a very scratch, like finished product of our recommender model. And so this slide shows a sample user input post with the topic title and the topic content. And so when we get a post like this, our recommender will take that post and then predict the 10 most likely tags that will be relevant to the post. Again, listed from the most likely to less likely as the list goes down. From that, the user can select and input the actual tags that they think are relevant to the post that they just wrote. And these newly inputted posts and tags by the user would then actually be put back into like a database for further active learning by the model to improve our tag recommenders performance like in the future. And I will pass this to Sai for more explanation on that active learning loop.
Thank you, Huan. So now that we had built the backend model, and in order to scale it for any real world application like LinkedIn or any forum that has a huge number of posts, it is not always possible from our end in order to throw a recommender and to predict for unknown category post as well. So we took advantage of active learning here. So active learning is a process where we give a chance for user to we label our outputs and send back into the system for retraining in order to improve our accuracy. So what we did here is like we predicted the top n suggestions for a post, let us say top 10 suggestions, out of which user selects the 4 or 5 relevant tags he thinks that are more relevant for that particular post. So that will be taken as an input for us, and we store that input and retrain our model in order to improve our accuracy. Well, you can see that architecture here. In the right side of architecture, you can see active learning loop, where we show the predictions out of which the user will be annotating them, and that will be sent back into our model where we retrain it. But how efficient is it to retrain it for every new input? Is it possible for a real world scenario? No, I don't think so, because we have a lot of social media or any forum websites that have tons and tons of posts. And for every new post, if we want to retrain our model, that would be super inefficient, considering that we had a lot of GPUs involved and the computation cost is going to be more. So how we faced the challenge? So we took the advantage of having a buffer. So we created a buffer database kind of thing in order to store the first 50 inputs and batch process it. For every new 50 inputs, we batch processed it. And later we can scale it up depending upon the flow and the traffic involved in the website. We can still scale it up, but that is a concept which we used is like buffer, where we batch process it for every k inputs so that we can improve the algorithm efficiency in terms of time complexity. So that is how we took advantage of it, and this proved wonders for us. This active learning essentially improved our performance. So you can see that in the visualization, where before active learning the accuracy stabilized around 79 kind of thing for test accuracy for unforeseen data. Whereas after active learning, for very small input number, like for 50 new inputs, it improved till 81, which is very good considering the real world scenarios. And for huge number of new inputs, it is going to be improving a lot and stabilizing at a better position. And that is how we made it, ensuring that this model works perfectly in considering the scalability part and the reliability part, because we are taking the user inputs back into our system and retraining them. So it will be highly scalable and highly reliable. So how to make this model an end-to-end solution? So now that we created an entire backend of it, we thought of creating a UI for it in order to show it to user. Instead of talking about the programming part, we would like to make sure that it is like a product which can be usable. So we try to deploy it into Streamlight and make it into a user-friendly thing in order to make sure that user can see it, what is actually happening there. So in the next slide, I'd like to show you how it looks. So you can see that the user initially gave the inputs in the left part of the slide, where our predictions are there, the top 10 predictions which appeared for that particular part on the right side of the slide, out of which the user selected 4 to 5 relevant inputs. You can see that the highlighted in the pink color. Out of those will be sent back into our system as inputs from user, and we will be putting that into our active learning loop, and we'll wait for every k new inputs and batch process it every time so that by retraining, we can improve our accuracy. So this is how we tackle the problem. And we can also suggest how this end-to-end tool can be beneficial for STEMaway platform. In the next slide. Yeah. So if you can see now, the STEMaway being a new platform and growing platform, there are a lot of posts which are untagged. And there is a lot of unforeseen data till now. So in order to make sure that we cannot tag everything manually, that's not possible. So we can try our algorithm because it is trained upon Stack Exchange, where we have tons of data and tons of tags which are relevant to almost every field of a computer science or be it bioinformatics. So there are a lot of data which is available from Stack Exchange. So we train that algorithm, and also we are using active learning from it. So that would be highly reliable and highly scalable considering the ever growing platform like a STEMaway. So we can actually try this for predicting the new content and the existing content and giving some tags for it. Over to Sal.
Perfect. Thank you so much for that, Sai. Uh, so now that we have shown the backend work and the user interface on how we deployed it, let's consider what would be our conclusions and where do we see this product going into the future. So given the product requirements the project statement that we had in the start, the project requirements that we came up with in collaboration with stakeholders and mentors, in the end, we were able to propose a machine learning model with a really high accuracy for predicting tags instead of the user choosing tags. We made an annotator tool which made the which encouraged tagging behavior. Instead of people looking down drop down lists, it actually popped the most relevant tags for you. So we actually made the annotator, and then we actually integrated the active learning loop. We were using all the new comments that were written by users with their tags to retrain our model time and time again to improve our accuracy. And we, as Sai mentioned, we improved our accuracy from 79 to 81%. And that's the only slide we could generate, because I remember at the end of our project, when we were just playing around with it, we had increased its accuracy to around 85%. And that was not that and we're still anticipating more improvement with the additional data coming in on the STEMaway forum. So that's like a huge success for us, benchmarking our performance at 70% and then having a model that was giving an accuracy score of 85, around 85%. So in conclusion, we were very happy with the model performance and the product that we made. But what could be possible future work, right? And we really thought about this problem like, it was like we're the ones who are going to solve it for the whole world or something. And we were trying to get into the complexities of it by the end as well. And there were a few things, like even though we had a model that would predict for us, there were a couple of things we felt like that could be improved. Right now we were constrained to a 25 tag list, or a 25 tags per pathway. STEMaway has different pathways: bioinformatics, machine learning, user interface, user experience. And there we restricted ourselves to 25 tags for each of them. We want to improve this, like users would say things that might not be in the tags, and what kind of things would be predicting then. And what we thought was we can set up a deep learning model that can actually go through the new content that a user inputs, and then has a way of looking at the content and suggesting new tags. And in addition to the 25 tags that we already have in the list, we should have the ability to suggest the new tags given the content that they feed to our model. And Sai is going to talk about the next two ones because it was his idea.
Sure. So initially we proceeded with Streamlight considering the user friendliness of it. But I believe that for future purposes, I can go for Flask instead of Streamlight, considering the lot of customizations it offers for complex UI processes as well compared to Streamlight. So the other thing which we are trying to focus upon is like, uh, there are a lot of users that will be suggesting different tags for the same context that we already see every day in social media. So we are trying to see how our model behaves for user-based variation effect, that we would call it like that, where for the same content, they're trying to give different tags. So in that case, how effective is our active learning loop? That is what we want to focus upon. And that is what we have been trying upon to improve our accuracy time and again. So these are our future works, and over to Saad.
Perfect. Thank you so much for that. And that is the end of our presentation. I'll open the floor for question and answers if there's any. Pratik, this is towards you. We would love to get your feedback.
Actually, I was taking notes, and first thing that I wanted to mention, I'm not just cliche dishing out compliments over here, but I really appreciated how really articulate and very clear and concise each of you were. That is amazing. I really appreciate that.
Thank you.
I do have a few questions that are let me pose a few of them that are in increasing order of openness. The first one is more of a comment. So you have this model accuracy prediction slide that is a few slides back. Yeah, we just crossed that.
This one.
No, it was
The
well,
visualization part.
that's right.
Active learning.
Active learning. Okay.
Yes, this one. So here is an example where it is really, really important in almost all presentations. When once you put two slides that are next to each other side by side like this, the y-axis should be on the same scale. If you put them above and below, the x-axis must be on the same scale. But ideally, both the axes should be comparable if these graphs are sort of comparable. You are, of course, using the same colors and so on and so forth. So that's just a comment. I could ask questions related to the actual findings and techniques, but I wanted to ask you, when you came from 480 possible tags to 25 tags, how did you choose these 25? What kind of analysis went behind choosing these 25?
I
You can speak to that.
Okay.
Everybody has an
So
answer.
yeah, we chose those 25 tags depending upon STEMaway based relevant tags as well as the top predicted tags. So it is like a combination of top, let us say we want to generate 25 tags, out of which it is a combination of top 10 to 15 tags based upon the frequency of it, and also the relevant tags, especially for STEMaway, because STEMaway has some leadership aspects as well. So we combined those both in order to get an efficient bunch of the relevant 25 tags, which we feel those are explicitly for STEMaway.
So you hand selected some of the tags, is that right?
Yes. So
Yes.
we initially just shortlisted what I would say around 40 tags based on the frequency of tags, because we wanted to have a huge data set, because we were shortlisting from the 60,000 data points that we initially collected. And from those 40 tags, we realized that not all of them are going to be relevant to the pathway that we were trying to apply this on. So, and this was done in collaboration with other teams who were working on building the same kind of product. We sat down with our mentors and we decided that these are the tags that we want to have on this part of the forum.
Okay.
So, yeah.
Okay. Sounds good. There are technical issues behind that, of course, because the most likely tags are not necessarily the most informative tags.
So there was a huge data class imbalance problem, which was related to the machine learning tag that we had, and that's where we couldn't do the probability threshold prediction type, because if we only got one tag as a prediction, it would 90% be machine learning.
Yes.
Right.
And we knew that there are techniques to improve data imbalance, but the information that we would be creating the new information out of was also imbalanced. So like even if I created new information, it would have still been imbalanced, So we just stuck to the data that we had and worked with it.
Yeah, so there are things that you could think of over here in terms of the most informative set of tags. So if you have CNN in there, maybe machine learning is not something that you want to include based on your data set, of course, right? If you have CNN, then deep learning is probably not what you also want to include, because there's so much overlap between them. Maybe just choose deep learning and drop CNN and so on and so forth. So there are issues of that sort that you've definitely started looking at. So I understand you were aware of these issues. Slightly more open-ended question. There are two places where you showed diagrams of how you would architect the system. One was for active learning. The other was right at the very beginning. You were showing how the whole process would work. Did you consider the risks of designing the system this way? Are there other alternate designs that you considered and then discarded?
No, since we made the system from scratch, this was the one and only system that all of us could come up with for this problem, because we wanted to solve this problem uniquely for ourselves. Yeah, so this was what we thought was the perfect system for this problem.
Okay.
Yeah.
And I can perhaps highlight a few possible risks to think about over here. You are taking tags that are predicted by your system and making it extremely easy for users to select a few of those tags.
Yep.
That, over the course of time, is going to bias your tag set.
Yep.
And that is a distinct risk, which might ultimately, it has the chance of turning your tag set to something that is completely pedestrian and not very useful.
Yep.
So that's one of the risks. So this is something that is always worth thinking about. How can you make it very easy for users to actually say that I don't agree with any of these. I want my own tags, and actually reward them for that. Sorry, somebody was speaking.
Yeah, I would like to add a point there. So in order to tackle it, what we tried initially while web scraping is like, so you're talking about a scenario where user don't want any of the predicted tags, right? So there can be a customization which can be extending the user input along with the predicted tags. I mean, he can choose either any of those 10 tags, or he can write his own tag that will be, I mean, going into the system for retraining. So that is one thing we tackled it. I mean, we're trying to improve the accuracy for it. The second thing which we tried to having more reliable data is like we went to Stack Exchange, and while web scraping only, we took the most voted inputs, and the most voted inputs, we assumed that would have a relevant tags attached to it. Otherwise, people would be putting dislikes to it. So that is a strategy I would say we followed in order to get, I would say, reliable data. So what we did was like we filtered by most votes and get the relevant data, that because we felt like the most voted data definitely will be viewed by a lot of people. So if that is not relevant, they are going to punish it. So in that strategy, we try to make it as reliable as possible. But yeah, we'll consider these points to improve it further. I think, yeah, these are relevant.
And as it stands, it seems like your project is already very useful. So these are not critiques to your project, but in the spirit of the discussion today, these are the kinds of things that we have to think about when we design systems, because we have to think about systems that we want to design that will outlive us. I might design a system, I might improve it for a couple of quarters, and then I might move over to a different group. But this piece of software is going to continue to run on our servers, serving this purpose. So these are the kinds of things that we have to discuss. And this is something that we constantly challenge our colleagues, and our colleagues constantly challenge us. Just blindly walk into a room and say, what are the alternate designs? It's a very useful question, even though it's a dumb question, just a very useful question. It forces the other people to think about it. So having said that, I really enjoyed all of your discussions over here, and we could talk at length about the technicalities of some of these. I think that there is perhaps a little bit improvement that you could have made on the active learning side of things, because the active learning part is just taking in, it seems to me, all the labels that the user chooses and retrains with that. But the point of active learning is to be probing about the tags that we are least confident about. So if we know, if we are pretty confident that the tag CNN applies to a post, giving that to a user is not as valuable as giving, say, I'm not quite sure, it feels like birds should apply to this post, but I'm not feeling very confident of that. The value of user input over there is way more. And that is where the information gain is maximal. That is, it appeared to me you may not have considered that in your active learning system, but that is one of the core tenets of active learning, why people want to use active learning.
Perfect.
Sure.
Thank you so much for that feedback. And it was nice to be on your challenge side today instead of your teammates. I think we're all learning a lot from it. And the risk part and the second thing that you mentioned about active learning, I feel like moving forward, if I ever have a chance to work with this product again, those are the things I would begin with, given that we have the current architecture. I think in interest of time, since it's only scheduled till 5:30, I would love to pass the controls on to Jay and Jay Debaleena. I think you should pass the screen control to Jay.
Yeah, actually, Saloni is going next. I'm just passing it on to her.
Hi everyone. Thank you, Saad. Thank you, Debaleena. I'm Saloni Shah, and I'm currently doing my majors in Mechatronics and Robotics from NYU. So I really consider myself to be the part of this STEM Away internship program because I got to learn a lot of things, and talking towards something towards the design thinking process side. So here's my team. Anthony, I would really thank him as my co-lead, and the participants all were like really active, and they all made up a good team. So, STEM away, I would like to say one thing about the STEM away. It doesn't only focuses on undergrad or grad students. So Christine, who worked for this design thinking process, she actually got retired because she's a mom of two children, and we were lucky to have her on our team because she gave her inputs, and she was very valuable for our team. So I would really like to thank her. So talking something about design thinking process, so it consists of basically 5 major steps: empathize, define, ideate, prototype, and test. So empathize is where you learn about your audiences. Define is you come up with a problem statement. Ideate is when you are actually familiar with the problem statement, you try to come up with the creative solutions. Then the next step comes as prototype. So here's the two type of things: low prototyping and high prototyping. And then the final step is testing. So when you actually test your product before just coming up or giving it to the market. So moving next, empathy maps. So this was a very important step because the empathy maps can tell us about all of our users, what they want to hear, what they see, how they feel about the website, what do they say. So this uh, indirectly helped us understanding and empathize with the stakeholders. So right side, the picture shows that how actually people prepare empathy map. They just create a white rough draft on the wall, and then they put up the sticky notes just so that to make sure they highlight each and every point. So in this slide, you can see the empathy map that my team designed. So this empathy map was created considering this time away and what the users think about it. So here's the look for what my team did. Talking about the user research interviews. So I just want to talk one important thing here, as this is like very important step of our part or the process, because we interact with the users, we talk to them related how they feel about the site, what problems they feel when they first visit the Stamaway, what changes they think they should make it. So this was a very important stage, and it really helped us in drafting how should we designing our low fidelity and high fidelity prototyping. So we got some positive, negative feedbacks, and we used that, and it really helped us for displaying the relevant information to new visitors and reoccurring participants. So one thing I would just tell everyone is like, when we take interviews, so I would suggest that when you're actually interviewing someone in person, you should be completely hearing them, and you should take someone along with you to write down the notes, because when you speak with them and when you are concentrating on writing down the notes, they might just feel a little bad about it, because you need to hear them, whether it's negative feedback or positive feedback. So you should completely give 100% concentration when you are taking an interview or asking your user about giving you some feedback for your work. Next, talking about the personas, and it is just as important as we did our research, user research survey. So personas comes next. After talking to the users, after knowing what they think about the website layout and everything, we just prepare a draft, and it just shows that what a person or the user might think about us. So we used Mural for it, and we used the layout that a mural has, and we used the sticky notes, and it is very helpful when you have to draft. Let's say if even if you have to make BMC or any value proportions, the mural sites can help you with that. This is the next step. We moved on further with our wireframing work. On the right side, as you see, it's the done in Balsamic. It's a software, and usually we use it for the wireframing thing. It gives you general layout and idea about how your website or any applications on your phone might look like. So here's like the personal media library, for example, the iTunes. So this layout shows you that, okay, if you ever remember that, okay, how iTunes library look like. So there's a play button, stop button. You can adjust the features you want to give them and just create a draft so that you get an idea that, okay, what your final site or final product will be looking like. So the one, this is GSAL principles, and this was the one important thing that we all used it when drafting our layout. So this is the layout of our site that my team prepared in the Balsamic software. Using the Giselle principles, they are really important. They tells us how the layout should be. When you scroll down, the relevant information, when you put below the text box, all the drafting and the designing principles, we all followed that, and we made sure that our page should look like as if it's professional, and we wanted to make it look best. So this is the low fidelity prototyping that my team did in Balsamic. Talking further about it, the usability testing, this is a very important step. The generative research methods usually define the problem that we'd like to design a solution for, and the evaluative research measures on the other side, they helps us evaluating an existing design. For example, the prototyping or doing the final touch up or doing the final preparing final draft. So user testing and usability testing is like, what do my users think of? Is it going to be useful for them? How likely they'll be using my app if I designed? How likely it is going to make a positive effect in their life? So these are all questions we should ask to ourselves, so that it can give us a rough idea that, okay, what actually you should think from the user's point of view, that can give us the more creative solutions to our problem statement. The next I would like to move on is with the use of Figma. And I would really appreciate my team that they put great efforts in creating the layout, the final draft for the website Stamaway. And everyone can just go to the LinkedIn and we have posted the high fidelity prototyping of our design layout in Figma. And I would also like to share one thing. I was completely new to Figma, but after joining this internship, I got to learn a lot of things. And as a part of my curriculum present for the entrepreneurship subject, I used Figma in designing and drafting a layout for our own website. We are currently team of 7 members, and we designed the website snopty.com. It's basically a social platform where we focus on the native languages readers as well as the writers. So we just contact the writers and we ask them to write their blogs on our website. And it's for now we are concentrating on Hindi, Bengali, and Marathi. And we in future we are planning to expand it to other languages. So thank you everyone. I would like to give away my have a next presentation to Jay, and he will take you along the other side of this time away. Thank you.
Thank you for having me. Hi, everyone. I'm Jay. And thank you, Pratik, for being here and just giving us an opportunity to present our work at STEMaway. So, as Saloni talked about her experience as a mentor chains lead and leading the user experience and user interface team, I was a user experience lead as well, along with her for another team. But at the same time, some of the leads were also working on another project at STEMaway. So here are 4 of us. It's me, Anthony, it's Fiona, and Pooja. 4 of us were working on creating the user interface of a corporate dashboard for STEMaway. So STEMaway is not only just a platform for virtual internships or career networking. It is like a two-sided marketplace where students and aspiring professionals in STEM, like all of us, are given the opportunity to, kind of connect with corporate partners who are looking for young talent in STEM. What we were working on was STEMaway's hiring portal. And this is just a gist of what we worked on the initial design. It was called as version 1.0 of our initial design. And you can see that this particular design was kind of created to help recruiters or hiring managers input the kind of roles, the kind of roles or students they're looking for, especially. And then you can see different kinds of uh, inputs that they could put, like, technical skills or soft skills or other attributes, location preferences, things like that. And this is something that we just started off with. And there was immediate feedback on the active candidate pool as the recruiters or hiring managers kind of toggled between different kind of skills or preferences that they wanted. And in some part of this page, there were specific skill suggestions by role based on the library of resources that STEMaway has. Now, I'm going to show you the final version of how it looked like. And here we're just going to enjoy the power of Figma and UX prototyping and designing. And so this was the initial version that we worked on. And now let's see what the final version, which is ready right now, looks like. And this is much more clean, and this is much more, as Saloni mentioned about the gestalt principles. What it basically talks about is that there are sections within a web page as well. You need to relate to different sections. And what we can see over here clearly, and what we wanted to focus mainly, was an active panel and a result panel. Now, in the active panel, you are inputting, you meaning recruiters and hiring managers, they're inputting different kinds of inputs, like what kind of technical skills do they want, what kind of soft skills do they want, what location preferences do you want. That's the active panel. But then at the same time, on the right side of the page, there is a result panel as well. On the bottom right, I'll say, to be more specific, there is a result panel as well, where you can see what kind of inputs that you're putting. So you can maintain contact with each and everything that you're inputting, and at the same time you can play around in the active panel as well. So moving on to what my team designed, not my team but all of us designed, is you can see on the left hand side, there are technical skills that you're looking for a UX UI designer, skills like visual design, high fidelity prototyping, information architecture, and then you can put in the importance of that skill. What level of importance are you looking for that particular skill. Similarly for soft skills, and then on the right side you can see that there is a map, and then there are locations where you're looking for UX and UI designers. Now, all of this is quite intuitive and all of this is quite user friendly, but at the same time, this does not look as polished as the final version would look like. And moving on to the next slide, we'll be able to see what the final version actually looks like. So here we can see the page for the technical skills. This looks much more neat. This looks much more efficient and easy to use. Now, what was important is the color pattern, maintaining the color palette as well. When you're working with visuals, when you're working with graphics, it's important to make sure that the user is kind of connecting well with what the company has to provide. So we're choosing kind of shades of green over here, and that is something that we're highlighting in this page as well. And then there's once again an active panel and a result panel on the right side. The active panel meaning the panel where you can prioritize technical skills, soft skills, and then on the right side there's the result panel. So moving on to the next slide. So as we were talking about the location preferences, this is what it looks like. Now we can see how different it is from the initial design that we had. This is much more clean. This is much more uh, user friendly, and this is what putting in location preferences looks like. You have selected locations, you have working logistics, in person or remote. Remote is a very important option that all of the companies would like to opt for, keeping in mind current situations. So, and then once again on the bottom right hand side there is the results candidate pool, where you see that you know okay, so you have 82 results now based on the input that you have provided. So this is just a gist of what STEMaway's virtual online corporate dashboard looks like. So this is just the final version, just to show you the final version of, after after the hiring manager or the recruiter has inputted everything, this is what the final version looks like. You have a list of 43 candidates that meet the requirements that you've kind of asked for. And then you have their one-click resume as well. One-click resume is STEMaway's proprietary proprietary material to kind of display the different kind of skills that a person is showing, and it has a completely different algorithm behind it. But yeah, this is what the final result looks like. And this just ends the formal presentation part. And you could just see the power of UX designing for our corporate dashboard, and I hope you enjoyed it. But actually this is just a gist of what the STEMaway experience looks like. There are a lot of other things which you learn while interning at STEMaway. So let me just talk to you about my personal experience as a mentor change lead when we started the June session. Now, I was about to lead the user experience team of 8 participants, and our project was to work on STEMaway's online user interface. Now, some of you must be thinking, what if we haven't led a team before? Uh, There were certain apprehensions about leading a team for the first time, and now I was a bit nervous about it. And but what's unique about STEMaway and the entire experience at STEMaway is that they trust in you to lead by example, and that they're confident in your abilities. Now, in addition to that, all the UX leads were given 2 weeks of formal training from an industry mentor. Now, this training period actually boosted my confidence, and it clearly shows how invested STEMaway is in nurturing young talent like me and all of the other panelists present over here. Now, overall, my experience of leading a team in the user experience pathway helped me a lot during interviews as well. this is a very important part for students like us who are actually looking to enter the market for entry level roles. And this is not only something, the STEM away experience is not only something that will look good on your resume, but this experience will give you multiple talking points during your behavioral interviews. Now, I was able to talk about my leadership experience, about times when I failed to motivate my team, and then how I was able to overcome those, roadblocks. Now, this actually shows that STEM Away has given me a great platform to develop professionally and as a person as well, because when you're leading a team, you learn multiple things about yourself, about the team that you haven't even had a chance to encounter before. And I think this model of having mentor chains leads is exceptionally well structured. It's exceptionally well designed, and I think it is a great platform for you to excel professionally. So I just wanted to thank Debaleena for this opportunity. And this brings an end to the presentation part, and we can now open the floor for questions. Thank you.
Thank you, Jay. The pleasure has been mine working with such an exceptional group of students. But Pratik, do you have any questions for the UX team, or if any of you want to add to your experience part of it before Pratik starts asking questions? Saad, do
I'm gonna
you?
say a couple of things and then I'm gonna head out because I have another project meeting in like a couple of minutes. So I think the whole experience, just reiterating what Jay said, it was we went into a field. I'd only taken one course into machine learning, and when I became a part of this cohort of students, they told me that you're gonna be the lead, the technical lead, and that kind of put me in a spot where I had to learn how to lead, and I had to learn everything I could about machine learning at the same time as well. So it really took me from 0 to 100 in a matter of like 3 months. Like I was exceptional at leading my team. I think we exceeded all the expectations that were put in front of us, and I exceeded my own expectations, to be honest. And at the end, like Jay said, this is something that's not just on your resume. It might look like other places on your resume, but when you actually start talking about these things in front of employers, they're like, wait, let's talk about your STEM aware role. You said you were an intern and you were helping 6 other interns. Wait, how was that? What was that experience like? How did you manage expectations? How did you manage dividing up tasks with people and things like that? So, and I think this is just gonna grow. Like I've been encouraging everybody to, like, just take up this opportunity with school, because I know you can. Is that is right, Debaleena, right? Like we can be a part of STEM away while we're going to school and still be part of these awesome projects. So I really encourage everybody to do it. But I am beyond grateful that I was a part of this. Like it's something I did not know when I was signing up, but I would not have signed up for any other internship after this. Thank you,
Thank you,
Debaleena.
sir.
I'd like to add a couple
I'm
of
gonna.
points.
It's a goodbye from my side. I have another
Okay,
meeting. Thank you so much for being here, everyone. Thank you. Thank you,
sure,
Nice
sure.
meeting you,
Debaleena.
sir.
Bye, Sai.
Thank
Bye,
you,
sir.
Pratik.
Well, I'd like to add here my experience as well. So when I started with June, like I started from summer onwards. So I've been part of both full stack pathway and machine learning pathway. So it was a first time experience for me being a junior professional, handling other interns which are of same age level, and how to manage them within the short period of time. And the deadlines are extremely ambitious here. So that's the one thing which I learned. I learned how to thrive in fast-paced environment that is very much required for industry, because um, even considering my prior work experience, also I felt the same. And here I learned more about how to solve the conflicts. In that case, like a lot of people has a lot of opinions. So how to come together to form a single opinion. That was my most learning experience. And also I learned from talking to Debaleena, like how a product owner expects the product to be. Like, being a developer, I always think about how which tech stack I can use and how to make it very beautiful in terms of tech stack. But while talking to Debaleena as a business owner point of view, that is very new for me during for the first session which went through Debaleena, and that was a very good learning experience for me. It actually enhanced my capability to think from other point of view as well. not only from a developer point of view, but as what exactly customer requires, what exactly business owner thinks about this product, and how to make it marketable and scalable. So that was the most learning part of me, which I didn't get through all my academics, I would say. So I'll be frank on this. So these are my new points, which I got it here, which I never got it um, during my experience. Like even I worked for a company for 1-2 years. There also I was not given this much exposure. So this was like a tremendous exposure in terms of knowing different viewpoints and how to handle this situations where we have tight deadlines, or be it how to handle the difference in opinions, and also how to take ownership of things. This is the most important thing which I learned here. Like we were given choice, go with any algorithm, go with any tech stack, but make things happen. So in that case, if freedom is given to us, how to take the right decisions by talking, and by having a lot of meetings. So and making sure that we are not crossing the deadlines. So this entire thing was a very new experience for me, and even it helped me during my interviews. Like the same like Saad. They were surprised when I mentioned that I, being an intern, managed other 8 to 10 interns. So tell me about that experience. So that was a very catchy point for me in every interview, and that helped me to go across behavioral, beat any question they have. We had a ready-made scenario for this, because almost all scenarios we faced it here, at least from a junior point of view. Whatever interviewer expects me, like tell about any situation, I can connect it straight away to my STEM experience and easily tell about it. And I can even elaborate with my, without losing my emotion to it, remembering what happened at that time. So I think this was a very memorable experience. I would definitely recommend. I already recommended also, so like some of my friends, to go ahead with this program. So yeah, this was a wonderful experience for me in terms of both technical things, because I was not that much expert with machine learning when I started with this. So in that 1-2 weeks only, we started to gear up ourselves, spend more hours of time researching about it. So yeah, I learned actually how to thrive in fast-paced environments and with uh, collaboration, I would say. So that's a beautiful part of it.
Thank you, Sai. So Pratik, all yours, what do you think now? We are eager to hear.
It's actually really great to hear all of this energy and enthusiasm, and that is grounded in actual experience. So I'm really excited for what STEMaway is going to continue to do. Uh, I I have been actually blown away by some of these presentations, to think that these were put together in the space of a couple of months or 3 months by people who are claiming that they didn't have any background in some of the necessary fields, some of the things that they had to work with. So this was really amazing. So I individually, I found each of you, each of the speakers, to be so articulate. Even at the end, when you're talking about these open-ended experiences, you're very articulate, and even with the slides, you're very articulate. I feel like I should come and get some real-life training from STEMaway.
We'd love to have you come, not for the real life training, but the project that the machine learning people, that Saad's team did, thinking of taking it one step more. So I'll reach out to you to get a little bit more feedback. Now you've seen the details of their work, maybe have the next group of students iterate on it and come up with an actual product. I would love to have them have a product to their name.
Yeah, this is great. And for the UX part, I actually had one high level question that I would have liked to ask both Jay and Saloni.
Yeah, sure.
Is UX often focuses very much on the tools. By the way, UX research and UX design both have reached a level of excellence now that wasn't there 15-20 years back. A lot of people were talking about UX research as an HCI, but today, I mean, I used to work at a place where UX research was really taken seriously, and there were anthropologists who used to work amongst us, who would try to understand how users interface with technology, what to do, what not to do in the very big picture of things. So already the kinds of thoughts that you've had and the processes that you've gone through are amazing. These are some of the same kinds of processes that we at our workplaces have our UX researchers do, our UX designers do. They use some of the same tools, of course.
Yes.
And one of the consistent problems that I think UX research or UX design still has not addressed completely is, how do you get to predict whether the end result is actually there? Ease of use is one thing.
Yes.
But are you actually helping your users? In your case, the corporate hiring manager.
Yeah.
Are you helping that person get to the best possible result that they can? So I'll give you one example.
Yes.
This kind of faceted search, you put in different criteria and you sort of filter candidates, you figure out how many do I have left. So it gives you this feeling that, okay, now having put in all these criteria, I still have 50 candidates to look through. I must be looking at the 50 best matches.
Yeah.
But honestly, I don't know if that is true. If by putting in a criterion that I think I need somebody who really needs to know about positive metrics factorization, I might have narrowed down my pool, but I'm not quite sure what I'm missing. So that is one specific example of a question. After having gone through that process, and the process makes it very easy, it almost is too difficult for me to not take the choices that you have designed in your system, right? I would actually enter all the criteria, look at the numbers, and then gradually settle down. But how would I know if I've missed out on somebody?
No,
and that is something that I think UX design, it's a very difficult question to answer, because how would you even measure that? But it's important to think of in the long term.
No, it's a great question, and I think it's a general problem that we tackle all the time, we face all the time as well. I think that has to do with, so the solution to that has to do with usability tests. I think you conduct more and more usability tests. You let more and more people, and people who are actually more than 100% invested in your product interact with it, and kind of just conduct usability tests, and you just see if they're kind of getting the desired results from this particular product or not. Because the entire new product development process, it's not only about UX research or not only about UX designing or actually developing it, but in the end you have to test your product, you have to conduct user tests. Because if you don't conduct proper user tests, the entire process might not be useful. So it's important that before you actually launch something, you kind of run tests. So we actually met with people from different companies that we've partnered with. We presented it to them, and after that we kind of gave them scenarios and situations to just play around with this particular corporate dashboard. And you know out of all the presentations and meetings that we've done, we've got some great feedback and in-depth questions like you asked us as well. So I think that would be a good way to move forward. As you said, it's a very difficult question to answer, like right spot on, but probably I see the process to getting there, providing the exact product, exact solution that our user wants. I think conducting usability tests over and over again with heavily invested stakeholders, I think that is one important process that we should implement. And I hope this makes sense.
No, it makes sense. There is also one thing about STEM is that you can work fast and furious on a project, but you come out of that project with ideas and knowledge of the problems that you don't actually have to work fast and furious on, but those should keep on working in the back of your mind, and you'll interact with many different kinds of people that get exposed to many different kinds of ideas, and maybe 5 years down the lane, you're going to come up with an idea that sort of says that, oh, this is a problem that we weren't able to address at that point of time. Maybe this new field that I'm just learning about provides some opportunity for interdisciplinary work where we don't have to develop anything fast, but we can start developing something new. So that's the high level philosophical. If you let me sort of start waxing philosophically, I can go on for hours. So I don't want to go on too much, but I just want to leave you with that thought.
Thank you.
It's very interesting, Pratik. I just, along those lines of working on something and then it affecting something else totally. The first time I got fascinated with data patterns was this concept of LFSRs, which are linear feedback shift registers. You guys might be familiar with it to some extent. But it's basically, it's just simply flip-flops attached to each other, and there's a certain way you attach it in a way that you can generate pseudo-random numbers. And when I first got it, I was, my background is not math, so all I saw was like gates. And I kept playing with those gates, trying to make, why does this create a pseudo-random sequence? Can I create it in some other way? Can I break it in some way? And obviously I couldn't, this was all basic math. But after 20 years, I'm at Intel and I'm working on error control codes. And it is that experience where I was crazily playing with these gates that I used to come up with the codes that actually met Intel's needs. So you never know. Today you're learning these things and tomorrow you might be applying in a totally different setting. But yes, it's all STEM. It's all, once you're into problem solving, and you guys have done a great job. I wish you all success. I'm sure you will find careers where you will really, really shine.
Thank you. And I would like to add one point to that. So as Pratik mentioned, I experienced that, once we'll do, a lot of my personal projects, I'll be racing up to complete it within a week or 2 weeks time. And later after 2 months, if I remember what exactly I wanted to do in continuation of that project as a future scope, I generally forget it. So that's where I started documenting all my troubleshooting steps. So be it troubleshooting or be it my future works, that actually helped me. And even for while installing our new instances like Ubuntu or a lot of instances for new interns, we started applying that formula and it worked well for us. Like we documented all the possible errors that could come. And also when we are done with the project, we documented all the possible future outcomes of it and continuation part of it. If somebody else may come, they can work upon the enhancements from that point of the time. So that is what I learned. I would add this extra point that the documentation part, along with the not only the troubleshooting part, but also step by step of how we approach to the project and what are all the challenges we solved throughout the project. So that entire documentation is a habit which I learned during this summer, and that helped me a lot in easing out my processes.
Absolutely. All of these side skills, which, sometimes they're not very exciting. The fact that you have to document and the fact that you have to interact with all of these people who don't think like you, it's sometimes very taxing, right? You wish that people would just think like you, but then to realize the strength in all of these things later on, that's definitely been one of the learnings of my professional life.
Yeah, couldn't have put it better.
Thank you very much, Debaleena, for having me. We'll touch base again soon. This was really an interesting afternoon. Time very well spent.